How's it going, everybody? In this video, I'm going to debunk a commonly misunderstood topic, and that topic is vSphere storage. Now, we're not going to go into any nitty-gritty details. We're not going to go into any like hardcore concept. Well, kind of. What we're going to be talking about basically is what's storage, why you would need it, and a couple of the pieces that make it up. You know, what's the difference between block level and file level storage, and how you can determine which one's which. So, give me a moment here while I pull up my pen. So the one thing that most people have a common misunderstanding on is storage. You know, everybody understands that on your computer, you open up my computer, you see C drive, and it's got so much space on it. You know, typically nowadays it's terabytes. Back when I got into computers, which was a very, very long time ago, it was kilobytes. I mean, back when I was first getting into computers, I think the first hard drive I saw was 100 meg. I mean, it was a really small hard drive. And this was a late 80s, I think. You know, I'm not that old, kind of. But nowadays, people are getting terabytes of hard drive space. You know, I've got a Dell computer here that's acting as my file server. It's an old Dell desktop. I'm using Starwind software on it to virtualize some hard drive space. I've got 2 3 terabyte hard drives that are plugged into it, one of which is a hard drive that does my media for like movies and video games and, you know, whatever else I decide to put on there. And the other hard drive is for hard drive space. It provides the iSCSI target for my ESXi environment, the ESXi environment you are currently looking at. So 95% of the hard drive space that's allocated to this host isn't even physically connected to this host as a plugged-in hard drive. 140 gig out of the 1.5 terabytes that I've allocated of storage to this particular host is actually iSCSI, meaning it is SCSI commands that are encapsulated inside of IP packets that are forwarded between the ESXi host and my Dell desktop, which is virtualizing the hard drive space via Starwind software. And the only reason it can be done is because somebody that's far more brilliant than I am figured out a way to virtualize and create a software SAN, software storage area network. So that's one of the concepts we're going to hit real quick is what's the difference between a SAN and directly attached storage, what's the difference between block and file level storage, and why do, you know, what's the difference between them? You know, why would you want one over the other? So before I get into any of the real nitty-gritty details, first, why do we need storage? You know, that's a very common question I get. Well, I hate to break it to you, and I hate to be Captain Obvious here, but how do you plan on saving anything? I mean, realistically speaking, if you don't have anywhere to store it, how are you going to save it? So, now, with that being said, I'm also a hardcore Cisco guy. If you didn't know, I hold a CCIE in routing and switching. So, that's what the majority of my videos here have been Cisco based. Well, the interesting thing about that is, one could argue, well, a router by default doesn't store anything. And you are technically correct, because the way that a router does things, and this is whether it's virtual or a physical router, you've got 2 different types of memory. You've got flash and RAM. Random access memory is what you do all of your network operations in. Your flash is where you store stuff. So 2 different physically, they're connected to the same motherboard, but they're 2 physically different types of media. The flash is where your operating system gets stored, your startup config, and any other minor details that would be in play there. Your RAM is what does all the operating. So when you boot up a router, the operating system gets decompressed from flash. So the iOS gets decompressed and loaded into RAM, because RAM is way faster, like way faster than flash. So all of your operations happen in RAM. Now, anybody that's familiar with a computer knows that RAM is what all of the different applications run inside of. Now, the problem with RAM is the moment RAM loses power, it will automatically lose whatever it had stored in it. So that's why if you don't save a router or switches running config, same thing with the firewall, and I'm talking Cisco-based products, everything will go away. So whatever you're running config, you can go in there and you can spend hours configuring your router. And believe me, I've been there, done that. I actually had a customer that they called me. It was actually a friend of mine here in this area. He's a Microsoft guy. The customer asked him to do some Cisco work. He calls me up. I was a CCNA at the time. I get on site to do some stuff to the router. Come to find out that nobody knew the login information. Well, being green and new to IT, I decided, oh, just do a password recovery on it. Here I'm thinking I'm the smart guy. And so I go ahead, I reboot the router and bring it back up, and I go to do a password recovery, and I log in, and I go to do, more flash colon running config, or startup config, nothing's there. And I'm like, uh-oh. And I'm like, there's no startup config. Oh, crap. And so eventually I rebooted the router again, and it brought it back up, and it was, welcome to the initial configuration dialog. I'm like, oh no. If you see that, that's a bad sign. That means that the router has a blank configuration. Other than the defaults that come with the operating system, there's nothing there. They forgot, whoever this person configured it, forgot to save it to storage, which is your flash. So that's kind of where I was going with this. So you're like, why is he talking about routers? This is a VMware thing. You're absolutely right. But it played into it. So if you don't save your configuration, you'll lose it. That's the whole idea with RAM. So the flash piece of it is where you store everything. So again, if you don't have anywhere to store it, how are you going to save your work? Kind of see how I wrap that in there. So so that's where that piece comes into play. The big thing that most people, I don't want to say miss, but they don't completely understand is storage. Storage is probably the most well-known part of any organization that I see, because it's usually located in an area that nobody ever goes, the data center, and it is, everybody just takes it for granted. It's just there. You know what I mean? So one of the first things I'm going to talk about as we go through here is how you would very quickly here in the next couple of minutes, we're going to break down how you would set up storage inside of ESXi and the pieces that go in to do that. Now the very first thing I'm going to show you here is actually going to be the storage setup that I have. The storage setup that I have is that Dell desktop I referenced just a few minutes ago. That guy right there is running StarWin software. StarWin software allows me to virtualize hard drive space and then serve it up to another computer as an iSCSI target. So my ESXi host acts as an as an iSCSI initiator. So the initiator reaches out to the target and says, hey man, show me what you got. So he goes out there. As long as everything matches up with their information, he calls out to it, he brings that information in, and whatever the target advertises to the initiator, so the target being the server, the initiator being the client, he pulls that information in, and then voila, then you have your data. And it's like, haha, I've got you. So now you could take that hard drive space and you can do with it what you want. You can format it VMFS, or you can just let it sit there as unset up hard drive space. So the first thing you need to do when you're setting up iSCSI is you need to create a different vSwitch. This is a different vSwitch needs to have a connection to wherever the storage is going to be advertised from. In this case, I have a dedicated gigabit connection between my Dell desktop and my ESXi host. It's a crossover cable. This is between them because there's no switch in between. And from there, all it does is it's configured here in storage adapters. I happen to have I've configured the iSCSI software adapter, which if you don't already have this set up, if you click on the add button here, click on add, a little pop-up box will come up. You click on add the iSCSI software adapter, you click on that bad boy, it automatically installs it for you, and then you kind of come down here and you got to configure it. So what you do here is you go to the network configuration, and what you do then is all this area right here will be blank. You click on add, and then what will end up happening is you'll see VM kernel 1 on storage vSwitch 1, since that's how I have mine configured. I click on that, and then I map it to vMNIC 9, which is what I did. So I do that, and then from there, once it'll come up as compliant, and everything will come up as good. So it shows up as the physical adapter and the actual port group and the kernel adapter that it needs to be applied to. Then you go to Dynamic Discovery, you click on Add, and then you type in the IP address of the host that's serving it. So you go out there, 3260 is the default server port number for iSCSI. So 3260. 3261 is the client. So 3260 is the port that you're going to want to set that out to. You do that, and you click on Close. Then what you do is you go in here and you click on Rescan All once you have that set up. And then what's going to end up happening is the host will reach out to this target and say, hey, let me know what you got. Well, what will end up happening is the target will advertise to the client, which happens to be the host, what type of disks he's got. From there, you click on, this is storage adapters, so you map your storage configuration to the storage adapter. As long as they talk and you see stuff show up here, that's a really good sign, by the way. You then click on storage, and then from here you click on add storage. Now disk LUN is fiber channel, iSCSI, or SCSI, local SCSI disk, or mount an existing VMFS volume. So from here you click on next, and if there was I'm trying to think of how I want to put it. If a iSCSI target is available, it would show up in here. And you can only go one at a time when you configure this. But if you come down here, and you would, what you would see, you'd see the SR1 software iSCSI would show up here. You click on it, and then you go through the process to add it. And that's basically what it does. So if I go back down here to storage, you'll see right here where it says LUN, or logical unit number. All the LUN stands for 0, 1, and 2 simply means hard drive. That's all a LUN is. So it's right now they're mounted. They are configured as VMFS. So if we go back over here to storage, you'll see that the type is VMFS 5 because I'm running in ESXi 6.0, which VMFS 5 is the only one that's available in this particular version of vSphere. So that's how you would do that. So I know that's kind of quick and stuff like that, but that's not really what I'm here to show you. I'm not here to show you how to set up storage. I'm here to explain it. So now that I have a nice little area of whiteboard to discuss this in, what I'm going to break down here is how this all breaks down. It's actually pretty simple. So I'm going to bring this down to where the iSCSI kernel adapter is. Click on this guy and bring this guy over here. So from here, basically what ends up happening is you have a couple things that are going to go on. So let me first break down what a SAN is, and then we'll talk about the different types of what the difference between file and block level storage is, because then it'll make more sense. So a SAN simply is you have a host, and you have let's say we have 3 different storage arrays. These storage arrays can be any type of method you may have in play that serves up storage to another device. So let's just say, for instance, we have this connected here, and we draw a line, and this guy connects to here, and this guy connects to here, and this is what they refer to as a JBOD, or just a bunch of disks. That's all that really is. And JBODs could be, this could be EMC, this could be NetApp, this guy could be Starwind for all it could be. No, they're just a bunch of disks at the end of the day. And then what this guy does is this connects down to a switch of some type. This could be fiber channel, this could be fiber channel over Ethernet, this guy could be iSCSI. It really doesn't make much of a difference at the end of the day what protocol is used to serve up the storage, because things like the MDS, the Nexus 7K, a 3750, a 6509. These are all examples of switches that can support a storage area network. Now you might say, well, hold on a second, fiber channel over Ethernet, those can't go over a 3750 or 6509. You are absolutely correct. They cannot. They can flow over iSCSI though. So what's actually important here to notice is with fiber channel, that has to go, when you're dealing with native fiber channel, that can only flow over a switch that supports native FC ports. If you're doing fiber channel over Ethernet, you're doing basically what iSCSI is doing already, except for this is layer 2. They're actually both layer 2, but you can route iSCSI. I don't know if you knew this, because this is via IP. This is layer 2. So fiber channel over Ethernet is encapsulated inside of a layer 2 frame, where iSCSI is encapsulated inside of an IP packet. If you don't understand the difference between those, layer 1 is the physical layer, right? And I'll give you guys a quick little divvy on that. Layer 2 is a data link layer. Layer 3 is the network layer. The difference between this is bits, this is frames, this is packets. ESXi sits here, FCOE sits here, and well, you kind of get the gist of it. Bits, so electrical signals sit here. So that's how this all breaks down. So when you're dealing with this, that's why I said you can route ESXi. You cannot route FCOE. You can route FCIP, but that's getting way outside of the scope of this discussion here. So I'm definitely not a storage engineer by any stretch of the imagination. But if in order to use Fiber Channel or FCOE, an MDS or a Nexus 7K, MDS is used, and because I'm sorry, I'm actually incorrect on this. This guy does not support Fiber Channel. This guy only does FCOE. The Nexus 5K supports Fiber Channel. The reason why you might see MDS still in the data center is because it's got a higher port density than the 5K does. Because the 5K, I believe, has been replaced by the 6K, or it's the bigger brother to it, and I think they go to 96 ports. So a 248 port, it's a 2U switch. The MDS, I believe, goes to 380, something like that, is what the MDS does. And that's 9700, I believe, is the platform number. Don't correct me if I'm wrong. But like I said, I don't spend a ton of time in the data center. But that's where that would come into play. What's important to understand, though, besides what the switches can support, is what they're actually doing, what the SAN is. The SAN is taking all of this stuff right here. And actually, let me take my eraser and start to break some of the stuff down, because I'm going a little beyond where I wanted to go with this. The SAN is providing your data center, I should say, your data center. So the SAN here, actually, let me just go ahead and blow this completely away, because I'll just redraw it. I did a bad job of drawing it out from the get-go. So we have this guy. So you have your host. And you have, let's draw a second host, actually. Let's do this too. You have this, and then you have, we're going to draw out a connection here and here. And then we're going to have, this will be the LAN switch. We're going to go switch over to green, and we're going to say this guy right here, and come down to this guy. This guy right here is your SAN. Now your SAN is supposed to be completely separated from your LAN. So this is typical, though. With the Nexus line of switches from Cisco, you're actually able to bridge it to where the LAN and the SAN can be the same switch. So Nexus 7K connected to a Nexus 5K, something like that. But I'm not going to get into data center design at this point. So you have a situation like that. The SAN would then connect into, would have connections up to, say, this particular storage array, this guy, and this guy. So you would have connections coming up to this guy and to this guy, and then the LAN would go off to wherever it's going to go. You'd have your little group of end users here, and then you'd connect up to this guy, and you'd have Bob and Sally and Tom and Diane over here on this particular LAN, and they would be accessing these virtual machines that are sitting over here on these hosts. The idea with the SAN, though, the important piece, is that you have a bunch of disks that are sitting here on these storage arrays, and they could be thin provision, they could be thick provision, they could be fiber channel, they could be ESXi. That really doesn't make much of a difference. The SAN is providing the storage capabilities that are external to these hosts. So what you would do here, like I mentioned with the way that this guy works right here, is you would map a port here to a vSwitch here. The vSwitch gets mapped, and what this vSwitch does is it provides the protocol layer connectivity from the storage array through the SAN up to the host. The same thing here. So you use this port right here to map to this particular vSwitch, and then this is how your host is actually able to talk out to the ESXi targets to be able to talk to them. Because you're using an ESXi software adapter, the software adapter speaks ESXi, these speak ESXi, they speak the same language, the same encapsulation. So at that point, you're able to bring that data into the network, into the host, and then once the host does this. Now, the cool thing about dealing with VMFS, and you're dealing with what they call block level storage. So this is the host here. Block level storage is what they refer to as hard drive, right? So when you take, let's say this is LUN 0, this is LUN 1, and this is LUN 2. What you would do here on the storage array is you would advertise these 3 LUNs to the rest of the network, and then this guy would see them show up as, let's say this is storage 1, 0, 1, and 2. So you'd see storage 1, 0, 1, and 2, right? So what you would do is you come in here, and then you would see this come in, because you might have multiple targets handing out storage to your entire environment. So you might have it set up to where storage 1 hands off to host 1, and then you have 0, 1, and 2, and you have storage 2, and this guy's receiving storage 2, 0, 1, and 2. And then what ends up happening here is host 1 has this connection, host 2 has this connection to this guy, and they both see the same, the 2 different setups. So let's say this guy right here is 1 terabyte, this guy's a terabyte, and this guy's a terabyte. This guy's, all 3 of these guys right here are 500 gig hard drives, something like that. So depending on how you split up your storage will determine how it gets blocked out. Because the fact that these are ESXi and they're setting up as storage, when it comes to when they're advertising the storage out to the host, and the host receives that through the storage adapter, and you go to the storage tab over here, and you go in here and you say you click LUN and you go to format it. The formatting, the host sees the storage as directly attached. It can't disseminate between a directly attached hard drive, which means the hard drive is physically plugged into the host, versus something that's delivered over a software-based adapter, a SAN, storage area network. So you bring that capability into the play, and the block level storage means that the host formats the storage. Whatever type of LUN or whatever disk that it sees. So when it sees this ESXi traffic come in, it sees it come in as block level storage. Therefore, the host is the one that does the formatting. So you format it as VMFS5, right? So it gets formatted as VMS5, and from there you're good to go. Where file level storage comes in, file level should be pretty obvious. This is folder. Folder means that when you go in here, you are doing NFS, or network file system. This is going to be the same thing inside of Windows as NTFS, network technologies file system. This is what you do in a computer where, let's say for instance, you want to share out to the rest of the network. In Windows domains, it's pretty common for your network administrators, or I should say your systems administrators, to have a dedicated profile that you're stored on. So no matter where you log into the network, you would be able to, like they call them roaming profiles. So wherever you log in, as long as you type in your Active Directory credentials, you will automatically, whatever computer you're connected to, will download the profile from the domain controller, and then you'll be able to access wherever your file shares. Those file shares are attached to your profile, which that follows you wherever you go in the network. Not always the case. Not everybody uses roaming profiles. At the company I work for, we do. So folder level would be the same thing as you getting a share, which the share is just going to be a file folder. I'm just going to draw part of my drawing here. So this will be your file folder, and in here you'd have like a little green dot that's underneath that, and then it would be named whatever. So C:, C data, for instance. And what you would do is you would go onto a NFS storage device. In my case, in my network, when I set this up, I use OpenFiler. OpenFiler is a Linux-based distribution that allows me to run this as an appliance inside of VMware Workstation to provide shared storage. Now that brings me to my next setup. When you're doing shared storage, whether it's block or file, both of these guys in ESXi 6.0 and later support the ability to do vMotion between block and file, file and block, block to block, file to file. What this means is when you have the storage array set up like this and you have two hosts that are connected to the same storage area. What this means for you, the same shared storage, is that if a host over here has a VM that they want to move to this VM, so this guy wants to move down to here, you would be able to use vMotion. As long as these two guys have the same hard drive space allocated to them, you should be able to do so. So let's say for instance storage 3 and you have 0, 1, and 2, and both have storage 3, 0, 1, and 2. They would be able to vMotion only on storage 3 out of the gate. Until you would move storage 2 to storage 3, so if you happen to have a hard drive stored on storage 2, if host 1 has storage 1 and storage 3, he cannot vMotion from storage 1 to storage 2. Why? Well, I'll tell you why. Because the fact that host 1 doesn't see storage 2. So if you have a situation where you need to be able to vMotion a VM that's sitting on storage 1 to host 2, the only way you'd be able to do that is you'd have to do a storage vMotion to storage 3, and then vMotion from host 1 to host 2. That'd be your only solution because it's the way that it's set up. So by doing this, you're able to, that's the nice thing about storage vMotion, you're able to move the VMDK, the virtual machine hard drive, from one type of storage to another. That's the beautiful thing about ESXi that is available. I don't know if Hyper-V and Zen Server do that, because I honestly don't know. They probably do. But those capabilities are available. So that gives you the ability to move the stuff wherever you need to. Now, that's the piece that most people don't understand. When you have your storage set up, now, if you have directly attached storage, let's say your computer, your VM is installed in directly attached storage. So maybe you have a 64 gig flash drive or something like that, and you gave your virtual machine 20 gigs of hard drive space, and whatever. But you need to be able to vMotion from host 1 to host 2. You'd have to get it off of directly attached storage and put it on storage 3. So once storage 3 has it there and that it's allocated, it's actually you've moved it from directly attached storage here over to, and the VMDK is now sitting over here on storage 3, whether it's on LUN 0, 1, or 2. It doesn't really make much of a difference. You would pick and choose. You would choose, like, say, LUN 0, which is the very first one that shows up, and then it would show up as LUN 0 over here on host 2. They would both be able to see the hard drive at that point, and then you'd be able to do the vMotion. So that's one way you could do that. So that's typically what most people have a hard time understanding, is how that piece comes into play. At that point, you're in pretty good shape. Now, again, when you're dealing with going back to like VMFS versus NFS. VMFS, let me go to blue. This guy right here, the host formats that hard drive. So when you bring iSCSI arrays into the host, even though the storage is actually over here, this guy and this guy do, well actually, whichever host the storage is allocated to or learned in on and actually formatted on is where, and seen from, is where the formatting can happen. NFS is done on the server. So let's say, for instance, you have a computer over here. Let's say you got a server 2012 running here, and he connects out to, the rest of your local area network. So an NFS share. So what you end up doing here is you advertise this, this folder named, 1. And what ends up happening here is you advertise that as an NFS share to the rest of your ESXi environment. This guy gets formatted as NFS by the server here. You can't do that. You can't manipulate anything NFS from the ESXi host. All you can do is set up NFS, tell it the server and the share, and that's it. You do that on both devices, they'll both be able to see it. Then again, the nice thing about that is you can vMotion between those two devices. You'll be able to vMotion as long as the virtual machine contents are stored and it's an NFS share, then you'll be able to vMotion between them. then the same thing would happen as long as both hosts see this, they'd be able to vMotion it to, say, storage 3. Do a storage vMotion from NFS to ESXi. The cool thing about doing a storage vMotion is, let's say this NFS guy over here is natively thick provisioned. So we'll say it's a thick provision here, and you're finding that its storage performance isn't very good, and you want to increase the performance. Well, or you have some sort of you need to be able to shrink down the size of the hard drives, the VM's hard drive, whatever the case might be. The cool thing about this is when you do a storage vMotion from, say, NFS to VMFS with 5.5 and 6.0, you can actually go in and you can change the provisioning type. You can go in here and say you're going to go from thick to thin. And the nice thing about that is thin provisioning. Let's say you allocate 200 gigabytes of hard drive space to that particular virtual machine. What ends up happening with thin provision is it still has a 200 gig cap, which means that the virtual machine won't be able to use more than 200 gigabytes of hard drive space. But it will only write what is absolutely necessary for the virtual machine to write to. So if the virtual machine has only between the operating system and any applications that's got installed, if it only needs 30 gigabytes of hard drive space to write to, then that's all it's going to be taken up. The other 170 gigs is still going to be there, but not allocated, not in use. So what you could do is you could have other virtual machines taking up that hard drive space as well. So it allows you to be a little more hard drive space, keep your hard drive space a little bit more flexible as you're going through. So these are capabilities that you definitely need to be aware of and know how to deal with. So that's pretty much where it boils down to. So I hope this explains how this would actually break down. And there is a question: what is the most common design? Are you dealing more with both the core LAN switch and the core SAN switch as the same device, or is it still separated like you're in your drawing? I'm seeing kind of a mixture, honestly. It really depends on the environment, though. I know I have some clients that they run ESXi and everything goes over a single switch. I also have other clients that are, have everything going over. They have a dedicated fiber channel switch for doing fiber channel, and then they do a dedicated Brocade is a big company that comes to mind when it comes to the way that type of stuff works. And the drawback to it is not Brocade, but having two different network environments. So one for your LAN, excuse me, and one for your SAN. That can create problems. That's why Cisco came out with the Nexus line of switches, which allows you to consolidate them into the same box, which means your LAN WAN engineer can be utilizing the same cable as your SAN engineer. So that means that you could be running fiber channel over Ethernet and also have your LAN traffic, so your HTTP traffic and your FTP traffic and your voice over IP phone calls all running over the same wire. Now what this implies, though, is you're going to need to have very, very high speed links. 10 plus gigabit per second connections are going to be almost a requirement. I mean, I don't even seriously talk to customers until they are looking at 10 plus gigs, if not better. The common that I'm seeing is actually 40 in the data center, because of the fact that what's needed, especially when you start getting into lots of replication from, if you're using like Site Recovery Manager and you're doing like things like Veeam and backups, you're getting into a lot of highly resource intensive moves that you need a lot of data plane and a lot of high speed links to be able to support that. Especially when you go to diskless servers where they boot off the network, and so like there's no actual physical disk inside of the hard drive or inside of the server, and they're using the SAN to boot ESXi to the particular that whatever server blade that they're booting to, and that's, I know that's a very popular thing with the UCS platforms. I think it's the B series is the blade, and the C series is the rack mount. So you have a situation like that where you're booting ESXi off of the SAN. It gets installed locally to the server, and then from there, it's able to pull all of its information in from the SAN. And the funny thing about that is the virtual machines that are running inside of that ESXi host are stored in the same storage area network, or that same JBOD, as where the ESXi host was stored, and your end users are using VDI to connect into the host, and everything's going over the same cable. Your SAN traffic, your vMotion traffic, your fault tolerance and high availability, your management, I mean, literally everything is going across that wire. So that's why it's almost imperative that you have 40 gigs or better in order to pull that off. So I have seen customers try to pull it on gigabit, and it just doesn't do it. I mean, I see performance degradation inside of my personal network, and right now I've got my host right now. I've got a Windows 7 box that runs VMware Workstation, so VMware Workstation works on top of it, and on top of that, I have I think I've got 9 VMs running right now, and these 9 VMs are they are providing the connectivity for ESXi 5.5, 6.0, vCenter, a domain controller, some other stuff. And the purpose behind all of this is it's all virtual. It's all software based. And everything's going over a 1 gigabit connection. And do I see performance issues? Absolutely. I mean, vMotion normally would take just a couple of seconds for a normal computer. It takes about a minute for the vMotion to happen. And that's just because of the fact it's all in software. I'm actually, for my home VMware lab, I'm looking at getting 3 more HP servers with 64 gigs of RAM on them. And, how much internal hard drive space I have is kind of irrelevant to me because I have an entire SAN available to me. And I'm going to get like an 8-port gigabit switch. And that gigabit switch is going to be able to provide the SAN connectivity because it's all iSCSI, right? It's all layer 3. So I connect the switch to my my Dell computer and plug in the switch to these other hosts, configure their iSCSI their adapters appropriately for their iSCSI software adapter, and then away I go. As long as they all see it, they can all share the storage. Everybody's happy. But that's the important part because that's what I'm doing with my physical lab. Because I eventually want to go get my VCAP and my VCIX and data center virtualization, and then I'm a big fan of VDI. If you didn't know that, so I definitely plan on doing stuff for some Horizon View and some other stuff. So there's a lot of capabilities out there VMware puts out that I'm really interested in doing. So that's why I think understanding how storage works is a very, very important part. And this was actually the biggest hurdle I had when I was studying for my VCP, was understanding how storage worked. What's the difference between VMFS, NFS, block and file? What's a LUN? Why does it matter? What's iSCSI? What's fiber channel? A lot of stuff comes into play. There's another question. You mentioned FCIP a while back. Is that what allows you to do long haul replication? It is. It is what's available, and that's only available in the MDS platform. From Cisco, so MDS allows you to do that, and but there are requirements that need to be met within. If you're doing like active replication, I believe you need 15 milliseconds or better latency in order for that to work. I could be wrong on that, but that's what I thought it was. So stuff like that is what comes into play. So that is pretty much it. I mean, that in a nutshell wraps up what I wanted to cover here, because then that goes in. I went a lot farther into some areas than I planned on, but that's okay. So that's what I plan on doing. So I hope this has been informative for you, and I want to thank you for viewing.